My name is John Deen, and I'm going to wrap this up. I'm on faculty here at the University of Minnesota, and I've been involved in questions on analysis for some time. How many people here remember discussions about total quality management and theory of constraints here? There's a couple hands up, a few gray hairs like I have. That goes back 30 years, actually. And I want to take, unfortunately, some of the concepts that we looked at that time and argue that it's time again to take a look at quality, at robustness, at resilience, to be able to address some of the concerns. And I'm going to use especially some of the ideas developed by Dr. John Roberts, who was a graduate student of mine in the 90s in North Carolina as we looked at this issue. And what he did was really carry me into other industries and ask some of those questions. The previous question really is balancing or optimizing, and we're going to talk about optimizing a bit too, because parallel to quality is the question of optimization. So do we maximize production, or do we maximize robustness? And the usual answer I get back is both. And I think more and more, as illustrated by the last presentation, we can't do both. The second challenge with lack of robustness is actually a statistical problem, in that quality management argues that a noisy system with lots of up and downs in the system, ranges of performance, ranges of mortality, actually makes it more difficult to change the system, to measure the system, and to understand what's going on. And quality management talked about noisy systems versus closely managed systems. And of course, it comes down to quality and throughput in some cases, though in that case, quality should increase the throughput if we have the correct objectives. If I look back at my training, I should have done more economic modeling to understand the challenges in more detail. There was a burgeoning topic of operations research, and I think I should have studied more what's called non-parametric statistics, that averages don't count for everything, and we need to understand how to take into account the individuals within our populations, and hopefully I'll illustrate some of that. And as an aside, I should have paid more attention in immunology, because everything changed after I graduated as well. But in my defense, I'm going to point out that my first computer that I bought for $3,000 had one slot in it for a 360 kilobyte 5¼ inch disk. And so at that time, our imagination on what we can do was a lot more limited to what we can do now. And as mentioned, we're seeing a broad horizon of instrumentation that will really increase our ability to not only understand what's going on in our system, but optimize it and understand some of the challenges. Operations research has a number of different subsets of focus in there. Some of it sounds simple, like transportation or assignment of causes, but there's a lot of other subjects like dynamic programming, goal programming, nonlinear programming, queuing theory, that really haven't been introduced into our industry. And I think we have to make room for them. Operations research comes from World War II, and it was defined as a scientific method of providing executive departments with a quantitative basis for decisions regarding the operations under their control. Sounds pretty familiar. And yet, it's bypassed us to a certain extent within especially livestock agriculture. And I like this quote: "I don't always have limited resources, but when I do, I turn to operations research." And that defines our challenges in agriculture, especially right now as well. So if you remember total quality management, and these slides showed up in the mid-90s, the hero was Edward Deming, and I see a couple nods there. And he had a really cool quote: "We have learned to live in a world of mistakes and defective products as if they were necessary to life. We argue how much mortality is acceptable. What is the target full-value pigs?" And he said it's time to adopt a new philosophy in America. And he's famous for working with the Japanese industry. He's famous for working with Ford that developed the quotation, "Quality is job one." I don't know if you remember Fords from the early 1970s, but my father had one. And the expected lifespan of a Ford in most vehicles was actually 70,000 miles. And a lot of us can't even imagine that in the room when we think that's just breaking in a car. So there were real improvements in quality across a large number of industries. I should also add that, as mentioned, there's also a challenge of optimization, because if we're trying to improve and challenge our productivity measures and have an outcome such as profit, the question is, what do we put into that calculation for profitability, and what do we put into our constraints? In other words, do we look at the genetics as questioned, and how do we balance both productivity, which can, in some cases, I would argue, has outstripped our challenge to maintain a robust population, and yet I've done optimization routines, and I noticed, Mark, you have that in your title. Back in my PhD, I did a calculation matrix of 1.3 million elements to calculate an optimization routine for marketing pigs out of a farm in Ontario. And I also put a $50 bill inside my thesis to see who would read and try replicate that. And I took my kids along 10 years later, and guess what? It was still in my thesis. So there is a challenge on what we can do and how we can challenge some of those optimization routines and how we work through it. But the challenge is that we can't put everything into our constraints and say we can't change that. We have to say we have to be able to change genetics over the long run. We have to manipulate, and Mark mentioned it well, that we decided we were going to maximize sow output, and weaning age was decided by the sow herd and rejected what was going on an optimal basis in the whole enterprise. And as we localize our optimization, we don't understand enough. And again, where the geneticists are leading us is expanding that optimization and expanding that matrix of decisions that we have in place. And that's a challenge to all of us. They're complicated, and we need to understand not only what goes on our own farms, but we have to also understand robustness and sustainability. And I think we failed miserably on especially sustainability, where we allow externalities, not ourselves, to define what is the most economical way of addressing sustainability and robustness. And I'll have a couple examples. And so I've been known to quote, "You keep using that word. I don't think it means what you think it means." I mentioned in an introduction that Leman asked me some time ago, which is more important, many years ago as I began, which is more important, growth rate or fee conversion? And the answer is but the answer is not yes. They're both important. We balance out and understand both in our calculation. So it really begs the question in our industry, and this is me at my retirement saying, why is product failure increasing? As Mark mentioned as well, I talked about sow mortality for many decades, or a few decades ago, and I failed. It's still increasing, and some of the numbers over the last year look even worse. So first of all, what is our objective? And the objective of an input, such as a gilt, is to meet design expectations. And so what do you expect a gilt to do? And it's not the average of what the system is. That individual gilt, you hope and you expect it to produce 6 litters. That's a success. That culling after 6 litters, or in some cases 7, in some cases 5, we should celebrate culling and not treat it, put it in the denominator of trying to reduce it. We've got productive lifespan. We've got variation in sow unit output that has any number of quality challenges because we're trying to fit those pigs into a fixed space, into a nursery or wean to finish barn. We've got mortality and cull rates. And we have excessive sorting, which quality argues is, again, it's those pigs that are not meeting expectations that need to be sorted out, that need to be treated differently, that we have to address. And why? Well, first of all, there's biology. In quality management, they say unless you're paying close attention to that issue of product failure, you're invariably underestimating the economic costs. And we'll go into that a bit more. There's a lot of lack of measurement and analysis of inputs and outcomes and the relationship between both. How much do the qualities of the pigs going into the barn on an individual basis affect the quality going out of the barn? And so individual pig weight, for instance, has a huge predictive value on whether or not it's going to be a full value pig. And we lack many of the analytic tools that have been used in other industries. I'll just give an illustration. My first, I shouldn't say it's my first, I grew up on a pig farm, but I moved to North Carolina in 1992, and my first visit was out to a tin shed in southern North Carolina. I had never experienced heat and humidity like that back in Ontario. And I met Chester whites in a tin shed, and I didn't have the opportunity to take pictures at that point, but it was very distinct. The farmer had been told the slaughter plant no longer wanted his Chester white pigs, and he had to buy other European background pigs. And the Chester whites were in their stalls chomping on feed, looking around, and the European pigs were down on their side and panting and struggling to maintain pregnancy. And so that goes back to the G by E. And yet we had to change the environment and understand how we manage this new challenging genotype in our population. So one other little story from John Roberts and myself. We went to one of the kings of quality management And he was Dr. Quisenberry, who worked with General Motors and not Ford. And he was on faculty at North Carolina State. And we explained how we were challenged with quality in raising pigs. And he finally said, it looks like it's more complicated to raise a pig than build a car. And we had to agree it was probably right. And the second thing he said is, you make things way too complicated, and the numbers you use need to be changed. So we're going to talk about that. They're complicated, they're messy, and yet and biology and reproduction is messy, and yet we try to fit those pigs into fixed facilities with fixed environments and hope the pigs fit into that model, and we limit the slack capacity, so the empty space that we have for fixing our problems. And we use other methods. We change weaning age if we don't have the right number of pigs to fit our nursery, with some of the real challenges there. Biological systems are difficult to monitor, they're subjective, they're expensive. He said, a system like yours should be spending 5% on monitoring. 5% of your cost of production should be involved in monitoring to fix your quality issues. And we just kind of rolled our eyes because we're a cost minimizing industry in many cases and can't imagine that much. And I think the challenge on instrumentation is really to imagine how many improvements can actually occur. We haven't studied a lot of interventions to improve that robustness, and we're seeing more and more. And we really haven't imagined how closely instruments can study the pigs under our care. And I really get nervous when instruments are designed to mimic what people see. My example is lameness. That mimicking the way we look at lameness is not a good method, because lameness isn't how pigs walk. It's the fact that they don't want to walk, that they don't want to stand up. And we should be measuring whether sows are getting up and down as much as they should, especially during lactation. A bit of a sermon there. What John introduced me to was a different type of quality management, and he talked a lot about Taguchi loss function. And all of you can look it up. There's many lessons on that. And he defined the total loss incurred by society to failure of a product to perform as desired. And so it says it's not only the failure to the system or the profits lost when a pig isn't the right weight or alive and walking onto the truck that you have to be concerned about. It's the welfare of the pig. It's the quality of the pig as far as food safety. The compromised pigs are more likely to have accidents or mishaps as far as pulling the pluck, for instance, on the slaughter line. And we can add more and more challenges once we use our imagination for those poor pigs. And Mark, you laid out very well also the challenges to labor, that it's not as fun working in a barn, especially on a Monday morning when there's been mortality, especially over the weekend, that sometimes hasn't been cleaned up. There's poor performance, operating costs, and we have to take a look at the side effects of the product in use. I added this point, and this isn't a Taguchi loss, but even more complicated in pigs is the upside and downside. If you take that loss function, there's a lot of difference. A heavyweight pig is a lot different than a lightweight pig. And the biology is totally different. So addressing heavyweight pigs is part of variation, but it's got a different pathology. And so you can develop, and this is an older graph, of a loss function, and we can start using that as an initial estimate of what we lose when we ship a lightweight pig or a heavyweight pig, remembering that there are other costs involved as well, including just the fact that we have to sort pigs and keep the barns running for longer when we have a variation in weight. So Taguchi talks about system design. It's innovation, taking a look at new ideas, applying science and engineering knowledge. And so sending students to engineering school is something we should start considering. Understanding inputs, the relationship to processes, and what are the parameters that are important for us in our system. What is the correct weight of a weaned pig to have a high expectation of success throughout the system? What are the other characteristics of a weaned pig? Because we can't always rely on sorting. Taguchi would argue it's the last step. If we're sorting pigs, and we all sort them, for going to market, for different characteristics, and we need to tighten the tolerance of what we expect coming into our barns and also what's going out of our barns. And Taguchi would argue you don't reduce tolerances without increasing costs. And that's where optimization fits in. I always put this one up with my students as far as talking about sorting. We have a wide range of pigs coming into our barns. There's pigs that shouldn't be there, pigs that need to be treated differently or euthanized. We have pigs that should be treated differently to make our targets, and then there's the tough pigs as well. And we need to understand those characteristics, but in many cases we can't simply accept them. So I'm going to challenge you with a couple ideas, and then I'm going to run away and retire. First of all, statistics. And I've done statistics for many of you over the years, and it's not variation. It's not what you learned in university. It's standard variation is a variation analysis, and comparison of means is based on something called sum of squares. And many of you have heard that and forgot about it, but it's focused on averages. It's focused on what is the average going through our system. And it's got a real problem, as I mentioned, because the pigs under the average are treated the same as the pigs over the average, and yet we have two very different problems in our system. The other problem is that squared part. It emphasizes outliers. The farther it is away from the mean, the larger is the effect upon the calculations and the differences. There are other maths out there and used quite a bit in optimization schemes outside of agricultural production. One of the things I learned 40 years ago was target MOTAD, target minimization of total absolute deviations. And I've used it a couple times. And the idea there is, first of all, we're not worried about the average. We're worried about deviations from the target. If you're trying to wean 2,000 pigs a week, it's really a question of what are those deviations from the target, not how, on average, how many you produce. And really, it's not even total absolute deviations. You don't take the overages and the underage. You argue, what's our negative deviations? And so target MOTIND, it doesn't roll off as well, but it's the target minimization of total negative deviations that we need to be focused on, and what many companies focus on in the industry. And really, once we get there, what we should be doing is really simplifying our statistics and asking not only what is the total pounds we miss, but how many pigs are below target, below specifications for our systems. How many times a year does a sow unit underproduce the target? And frankly, I don't measure sow unit production by number of pigs weaned. I measure it by born alive, because everyone plays around with the weaning number to the detriment, in many cases, of the quality. Also, economics is different. It's not in your profit and loss statement. Loss function is something that we work with on a regular basis in many industries, understanding what happens when we don't have the quality. How much does a sow dying in the second parity cost your system? And it's more than you think. It depends on when it dies. It depends on the attitude of your labor. It's also a concern for welfare. It's also a concern on how readily can you replace that sow. And last of all, it's a concern because sows don't die spread out over the year. They cluster. And that clustering has its own challenge as far as managing replacement of mortality and culling. We need to add that to management accounting. We need to get batch loss systems. What is one of our successes was simply talking about full value pig and adding that into the batch loss systems for finishing a grow finish barn, closing out a grow finish barn. We need to determine our specifications. What's a good pig? What's good feed? What's a good laborer? We need to identify how people fix things right now. How do people handle slow-growing pigs, and how much does it cost the system to cull pigs, to keep the the turns on a barn going longer than we would if we didn't have those slow-growing pigs, and thus what is our optimality? We need to understand the determinants of our unders, our overs, away from that target. We need to understand in more detail the contributions that operations research can give. I've told you the argument of underestimating product and input failure costs. We have a need to use less averages, and I think instrumentation will help us in the future. We need to understand our externalities. I think this is a great opportunity not only to appreciate what goes on our farm, but appreciate some of the external pressures. We need to recognize that labor is going to be more and more of a constraint based on the current trends in our populations. Instrumentation is increasing. I look forward to it. And the last one is predictability is a virtue. Sometimes some of us make money over the lack of predictability. And some of us as veterinarians run around trying to address predictability, not address predictability, but simply clean up. And I think there's real opportunities to do that in the future. So I end with that. Operations research, when good enough isn't good enough. So thank you very much.